This is an example of law of sines and law of cosines. What are we given here? There is a polygon, and we are given one side, two sides. Then we have an angle here. Knowing that angle D and angle B, they are 90 degrees. So these are the given angles. Of course, the last angle, which is this angle, if we say DCB equals 360, the total angles of the polygon, the four-sided polygon, 360 minus 83 minus another 90 minus another 90. This will give us as the angle C as 96, 39, and 54. Now we are required to find this line, which is AD, this line AC, and AB. Looking at the problem, we will try to figure out how to start. So let's erase and then start the solution. After having a look on the problem, we could figure out that if we link the line which is BD and then have a look here. So this is BD. Okay. So we will have a triangle. This angle of this triangle is known. And we have a side and the angle between them. So this is perfect application of the law of cosines. We will find this side, which is BD. And then we can move to find this angle. This angle can be found from the law of sines. Once we find this angle is already here. So we can, from the summation of the angles, we can find this angle. So we have three angles here that are known, and we have all the sides also, they are known. This is 90 degrees. The whole thing in angle B is 90 degrees. We knew this, we could compute this angle, so we can find this angle. Now also this one in this angle, also this angle D is 90 degrees. We could compute this angle, so we can find the remainder. So we will have in this, we have in this triangle, which is A, B, and D. You start from A, going to B, then going to D, back to A. This triangle now, here we have one line that's known because we could calculate BD, and we have opposite angle, and we have this angle and this angle. And this is also law of sines. We can calculate AB, and then we can calculate AD. Let's show you the drawings and the steps of the solution after we erase and do the drawing. So now we have these two triangles. Now we have a triangle AB and D, and then we have also the triangle which is B going into C, going into D, and then coming back to B again. In this triangle we have two sides and the angle between them. If we apply the cosine law, we will find, using the law of cosine, we will find BD equals 596.6. So here we have the CB, we have the CD, we have the angle between them, and this is the solution of line BD. Since we have now two sides, so we know this side, we know this side, and the three sides actually, and this is the angle, we can use the law of sines and calculate either this angle, which is CBD, or the angle that we have B and D and C, this angle. So first we start here with the angle CBD, apply the law of sines, and this will give us a CBD, this angle now it is 26, 14, and 25 seconds. Now we know two angles, the 96 here, and we know this angle. We can use the summation of the angles to find the value of this last angle in the triangle. Why do we need this angle here and this angle here? So we can find their complementary angles on the other side, in the other triangle, so we can solve for all the sides that we have here. Now, so this angle now, we can subtract 180, subtract from the summation of 26 and the 96. This will give us the value of angle BCD. This angle, this is 57. Let's put it here, 57 degrees 5 and 41. So now we have these three angles here in this triangle, so we have to switch now, find this angle and this angle. Let's erase and then see the next phase of the solution. So now we found this length. This length is now known. We found also this angle, and we found this angle. This angle was using the law of sines, and this one was using the law of sines, or the summation of the angles, easier to find it. Now let's continue finding the other angles on the other side. So considering the new triangle, this triangle now, we will first calculate this angle. The whole thing is 90 degrees. This angle is 26. So the summation of the angles, 90 degrees minus 26. This will leave us with the 63 degrees. Then, of course, 45 and 35 seconds. Again, we have this angle is 83. We have this as 63. So 180 minus 63 plus the 83. Or we can just use the 90 degrees here, subtract from the 57 something, and this will give us this this angle. Now what do we have? We have a triangle that has this angle is known, the opposite angle to it, which is 83, is also known, and we have the other two angles. This is a perfect application for the law of sines. So this side and the opposite angle, sines of the opposite angle must equal, for example, AD, and the opposite angle to AD is the 63, from which we can calculate AD. This is the only unknown in the equation, and then we can also use this angle 32 and the opposite side with the same AD here and the opposite angle. They are known to calculate AB. Let's erase and show you the results. Of course, everything, all the calculations, they are listed here. I'm using the functions that I wrote for this law of sines and law of cosines. This will facilitate the calculations. At the end, let's see first, and then we will see how we are going to calculate. We'll show you the drawing to find the line AC. So now, after calculating this angle and this angle, this side, so we have this side, sine the opposite angle, and then this side and sine of the opposite angle. We can calculate AD as 533, 733. Again, we use this same side and its opposite angle, and then with this angle, and to calculate the opposite side to it, which is the AB, and the result would be 326 to 93. Finally, we still have to make a sketch for AC, this line, and then find its length. So this is the final phase of the solution, where we want to find the line AC. The line AC, what do we have here? We have already calculated this side. We already calculated this side. And what do we have? We have this two legs of a right triangle. So we can apply the Pythagorean theorem, 256 squared plus 538 squared, square root, and this will give me this this side. And by this, we have all the sides that they were required. AD, AB, and AC are now found. So sometimes when you want to solve a problem, you do not have to just stick to the original drawing of the setup of the problem. All what you have to do sometimes you just say, so what we did in this problem is that we removed this line and we connected this line so everything was clearer and we could start with the solution with no problems. See you in the next video.